Hello, grade 10. Here's the discussion to the last three examples in the slides that I sent to you last week. This is still about remainder and factor theorems. Let's have example number 3. Find the quotient and the remainder. When you divide 2x to the fourth plus 5x cubed plus 3x squared plus 6x plus 10 by 2x plus 3. Since we're looking for the quotient and the remainder for the given problem, then we have to use a long division or synthetic division method. But here, we're just going to use the synthetic division method because that's the shortcut for long division. All right, so let's set up our synthetic division. First, let's take the coefficients in the dividend. We have 2, 5, 3, 6, and 10. Don't forget to insert 0 if there are missing terms. All right, and our divisor is 2x plus 3. This becomes 0 when the value of x is negative 3 over 2. You can have 2x plus 3 equals 0. You solve for x, and you can get negative 3 over 2. To proceed, we're going to bring down the first coefficient 2. Then we will multiply 2 and negative 3 over 2. That will give us negative 3. You add negative 3 and 5. That is positive 2. Repeat the process. 2 times our divisor, negative 3 over 2. That's negative 3. You add negative 3 and 3. That is 0. 0 times the divisor, that is 0. 0 plus 6, that is 6. 6 times negative 3 over 2, that's the same as 6 divided by 2, and then multiply the result by negative 3. And that will give us negative 9. And finally, 10 plus negative 9 is positive 1. Remember that the last number in the third row is the remainder. So our remainder here is 1. And the rest of the numbers here, 2, 2, 0, and 6, are the coefficients of our quotient. And the degree of the quotient is always 1 less than the degree of the dividend. Our dividend has a degree of 4, so the degree of our quotient should be 3. So it's going to be 2x cubed plus 2x squared plus 0x plus 6. Or that is 2x cubed plus 2x squared plus 6. When using synthetic division, we have to be very careful with our quotient, because here, this is not yet our final quotient. We still have to divide this one by 2. I'll discuss, or I'll tell you later why we have to divide the quotient by 2. So for now, let's divide first the quotient by 2. This is x cubed plus x squared plus 3. Now, why do we have to divide the quotient by 2? Remember, our divisor is negative 3 over 2, and this is actually coming from the factor x plus 3 over 2. Is this the same as our divisor in the problem? No. So how can we get this kind of expression from our original divisor? We can factor out 2 here, and then you have here x plus 3 over 2. So when we performed our synthetic division, we actually just used this x plus 3 over 2 as our divisor. That's why we have here negative 3 halves. So how do we take 2 into consideration? Okay, you get the quotient first, and then you divide this quotient by 2, and your final quotient is going to be x cubed plus x squared plus 3. When you use the long division method, the quotient that you will obtain is x cubed plus x squared plus 3. All right? So you only you only add this step to your solution if the coefficient of the x in the divisor is not 1. All right, let's now proceed to the second example. This is example number 4 in the slide. Find the value of k so that when 2x to the fourth minus x cubed minus kx squared plus 4x plus 2 is divided by x minus 1, the remainder is going to be negative 2. So the problem only gives us an information about the remainder. There's no information about the quotient. So in this case, we can apply the remainder theorem. Can we apply the synthetic division? Yes, of course. But here, let's just use the remainder theorem to solve the problem. How do we apply the remainder theorem? First, we have to locate where the divisor is. It's x plus 1. And then we're going to find the value of x that makes this divisor equal to 0. And that is x is equal to 1. What are we going to do with 1? We will go back to the polynomial expression or function or the dividend. And then we're going to evaluate this dividend at x equals 1. When we evaluate, we're just going to simply replace all the x's with x equals 1. And that is something like this. Right? After simplifying all these terms, combining similar terms, everything, the result is a value. And that value is going to be the remainder. What's the remainder? It's negative 2. So we have now this equation, linear equation, and in this equation, our variable is just k. So let's proceed. Let's simplify everything. We have 2 minus 1 minus k plus 4 plus 2 equals negative 2. Combine similar terms, 2 minus 1 plus 4 plus 2, that will give us 7. Minus k equals negative 2. And finally, isolate k, we have k equals 9. So the value of k that will satisfy the given condition is 9. Right? So when you replace k here with 9, then this expression will give us a remainder of negative 2 when it is divided by x minus 1. All right, let's have number 5, the third example. Find the value of k so that x minus 1 is a factor of p. And this is our p of x. A given binomial is a factor of a polynomial if it gives us a remainder of 0. So we're still going to apply here the remainder theorem. Our divisor is x minus 1, and the value of x that makes this divisor 0 is positive 1. After that, we will proceed, or we will go back to our polynomial function and evaluate this polynomial function at x equals 1. When you evaluate, you just simply replace x with positive 1. And the result should be 0 since x minus 1 is a factor. What is p of 1? This is our function p, so we will replace all the x's here with 1, and that is equal to 0. This is the remainder, and this should be the remainder in order for x minus 1 to be a factor of the given polynomial function. Let's simplify. We have here 2 minus 1 minus k plus 4 plus 2 equals 0. We have 7 minus k equals 0, or k is equal to 7. So the value of k that will make this polynomial function divisible by x minus 1 should be 7. I hope you're able to understand how the remainder theorem works, how the factor theorem works, and when to use synthetic division or long division method. So after this, or after watching this discussion video, I want you to take your check-up quiz number 1. That is about synthetic division, remainder theorem, and factor theorem. So that's it for today. I'm just going to wait for your submission. Bye-bye, grade 10.